We are discussing about the complete explanation of questions comes in GATE 2000 comes under 2013, that too under electron devices. One more question. This is second one more question. In a forward biased PN junction diode, the sequence of events that best describes the mechanism of current flow is A. Injection and subsequent diffusion and recombination of minority carriers. B. Injection and subsequent drift and generation of minority carriers. C. Extraction and subsequent diffusion and generation of minority carriers. D. Extraction and subsequent drift and recombination of minority carriers. So the question is once again, in a forward biased PN junction diode, the sequence of events that best describes the mechanism of current flow is. The correct option for this question is A. Injection, subsequent diffusion and recombination of minority carriers. We'll explain how. Forward bias. The definition of forward bias is with respect to a single battery, whenever positive terminal of the battery is connected to P side and negative terminal of the battery is connected to N side, the PN junction is said to be under forward bias. But with respect to practical circuitry, a PN junction is under forward bias whenever P side voltage, that is voltage on anode, is more positive than voltage on N side, that is cathode side. Then the PN junction is said to be under forward bias. Whenever P side voltage is more than N side voltage of the diode, then the diode is said to be under forward bias simply. So here we are going with a diagram with a single battery. Under forward bias, holes are repelled by the positive terminal and electrons are repelled by the negative terminal of the battery. That is, it looks like holes are injecting into P side and electrons are injecting into the N side by the battery under forward bias. So this process at the first level is going to be treated as injection. Holes and electrons are injected into the PN junction under forward bias. Next, if you see P and N side, P side holes are majority carriers, electrons are minority carriers. So P side will have more holes and less electrons, whereas in N side, holes are minority carriers, electrons are majority carriers. So more electrons and less holes as indicated. So diffusion is the process of movement of charge carriers from higher concentration region to lower concentration region. So diffusion happens under PN junction, that too under forward bias. So diffusion dominates under forward bias, whereas drift dominates under reverse bias. This is a standard statement. Diffusion, a simple example if you are looking at, take a glass of water. In that one, if you pour one drop of ink, initially it will be at one place where it has dropped, and after some time if you look at, that ink has been spread uniformly throughout the glass and entire water will be of the same color after some time. That is nothing but initially it is at one place where the ink is very large, where the ink concentration is higher, and other side the ink concentration is small, and now it has been diffusing into the other sides. So always the natural phenomena is nothing but wherever you will get more carriers, that will be diffused into lower concentration side. Here also the same thing, P side more holes, N side less holes. So holes will move from P to N side and electrons are more in N side and less in P side. So electrons will move from N to P side. This phenomena is called as diffusion. Diffusion is the process of movement of charge carriers from higher concentration region to lower concentration region. Normally diffusion exists only under non-uniformly doped semiconductors. If it is uniformly doped, at that time holes as well as electrons will be same under every place. That is, there is no less or more number of carriers. So there is no non-uniformity, no diffusion. So the second process is nothing but diffusion after injection. Now third one, when the holes are moved into n side region from p side, they will become minority carriers and they will try to recombine with the electrons present in the n region. As well, whenever the electrons are diffusing from n side to p side, they will become minority carriers in p region and they will try to recombine with the holes in p region. So this is the process under forward bias. This process is called as recombination. So first process is injection, second process is diffusion, third process is recombination. This is a sequence of processes which describes the forward bias phenomena. So the right answer for the question is injection and subsequent diffusion and recombination of minor